Example 4 says the rectangular coordinates of a point are given. Find the polar coordinates of each. So now we're going to go backwards, right? So previous example wanted us to find the rectangular, given us the polar. Now we are given the rectangular and our job is to find the polars. So here are the guidelines or the steps for converting from rectangular to polars. Step 1, always plot the point first. So we're going to cross this out because we did not, I copy and paste this from your book. So our examples a little bit out of order. Step number 2, if x equals to 0 or y equals to 0, use your illustration to find r comma theta. And again, cross that out. Okay. Step number 3, if x is not 0 and y is not 0, then use the radius formula, which is the square root of x squared plus y squared, to solve for it. Step number 4, to find theta, first determine the quadrant, just like earlier, for example 3, right? Different quadrants, you have to either add a pi, half a circle, or not. So theta is always tangent inverse of y divided by x, and we don't do anything if we are in quads 1 and 4 because tangent inverse is restricted in 1 and 4 naturally. If you're in quad 3 or 2, then you have to add half a circle, which is pi. So let's practice. Are you ready? First, make sure you sketch it out. Okay, plot it out. This is rectangular, so 0, 4, 0 is x, 1, 2, 3, 4. It's right there. That tells us if I were to draw a circle, this tells me the radius is immediately 4, and the angle is just going to be at pi over 2. So look at that. I don't even have to do anything and to get the answer right away. It's always radius of comma theta. Radius is 4 and theta is pi over 2. Bam. Look at that. Easy peasy. Then let's sketch this out. You have an x value of 3, 1, 2, 3, a y value of negative 3, 1, 2, 3. So my sketch tells me I'm in quadrant number 4. Well, in quadrant number 4, as you guys already know, I'm going to use tangent inverse. So theta equals tangent inverse of y divided by x. Well, y, it's going to be a negative 3. X is 3. So that's going to be tangent inverse of negative 1. Whoa, that's cool because that's a negative pi over 4. Okay, so I got my theta. Now let's find the radius. To find the radius, we will use r equals the square root of x squared plus y squared. Radius is going to be x squared, 3 squared would be 9, plus the quantity, which is negative 3 squared, is also 9. So that will give me the square root of 18. 18 is going to be simplified that down to 3 rad 2. So I have an answer. Remember, it's always radius comma theta. So radius is 3 rad 2. Theta is going to be a negative pi over 4. I need a bit more space in that box. There you go. Now, would it be okay if you use positive angle? Of course. Okay, I'm going to write down here. Or what if we write 3 rad 2 comma 7 pi over 4? Why not? I can totally do that. If I don't choose to go clockwise on my angle, I can go counterclockwise. I would still get to the same exact dot, okay? And you can even get creative, right? Would you agree that you can even have an angle in quad 2 and then just make the radius negative? Of course, all of that is possible. So what I'm saying is that on a test, you can technically have infinitely many different answers. So it doesn't have to be what I have written here or what the book has in the back of the book. I mean, what the book has in the back as an answer. All right, you're on C. Let's draw it out. It's a negative 1 for x and a negative square root of 3. Well, square root of 3 is going to be in between 2 and 3 in terms of, in between 1 and 2. Between 1 and 2. Because square root of 1 is 1, square root of 4 is 2, and 3 is right in between 1 and 4. So somewhere here is where my dot is, right there in quad 3. Well, let's figure out my angle. Theta equals tangent inverse of y divided by x. Y is negative not 3, x is negative 1. That's definitely a negative, and a negative is now positive, so that's why it's in quad 3. So I would now have 4 pi over 3, right? Because that's the angle in quadrant number 3. Now let's find radius. Radius is the square root of x squared, which is the quantity of 1 squared is 1, plus the quantity of negative 3 squared, which is now positive 3. Oh, I made a radical sign way too big. So that will give me a value of 2. So 2 comma 4 pi over 3. Yep, totally okay to have. What if I write 2 comma and go clockwise, just like that? Of course you can. Negative 2 pi over 3 sounds good to me. You can also have that. And again, you can have different answer and still be okay, as long as your point still brings you back in quad 3. And that's example 4 for you guys.
Example 5. Directions. The letter x and y represent rectangular coordinates. Thus, it does. Okay. Write each equation using polar coordinates, which is represented using letters r and theta. So before we start, I will again remind you, okay, x squared plus y squared, it's always r squared. Then x is always what in polar? X is always r times cosine of theta. Then y is always what in polar? R times sine of theta. Okay, so these are the things that you're going to have to know. And write it down every time. So the more you write, the more it's going to help you. Okay, and you're going to memorize that much faster. So A. Currently, it's all in x and y. My goal is to get it all in polar. That means I shouldn't see any more x's and y, right? Everything should be in radius, r, and theta. So the first thing I see is they both have 4 in common. So I will factor out a 4. So I have x squared plus y squared equals x. Whoa, what do we see here, right? X squared plus y squared is r squared, yay, and bring down the 4, okay? So look, I don't have any more x's and y on the left side. I still have one x on the right side. So the right side, x is this, right? But x is always what? Equivalent to r cosine of theta. Yes, you can simply just replace it like that, okay? Now I will totally accept this answer the way it is, okay? If you choose to move it to one side, which I believe your book does, okay, so that way it equals to 0, you can also do that. But I will always accept the simplest answer. Whether you move it equals to 0 or not, it's still going to be in the simplest form. You can't really do anything else, okay? Okay, here we go. Example 5b. How do you write x equals -4? Okay, so this is a vertical line as a function in polar. So, well, it's simple, right? X is just simply what? R times cosine of theta. That's it. X is always can be substituted with R times cosine theta. And -4 is dropping down to -4. Voila! That is so hard, right? I'm done. Now your book likes to sometimes write it in terms of R. What does that mean? That means I'm dividing both sides by cosine. The reason they do that is because you can plug it in your calculator and easily check your answer, which is fine, okay? You can have either one. I would take R cosine of theta equals to -4, or R equals -4 divided by cosine of theta. Either one will both be, when you graph it out, you're still gonna get a vertical line. And yes, you will eventually will learn how to graph these. Example 6, the letters R and theta represent polar coordinates. Write each equation, I suppose without plural, using rectangular coordinate, which is x comma y, okay? So before we start, we will write down some key things that are important for us. So the first thing that I'm going to remind you, it's r squared. It's always x squared plus y squared. Okay. Another one that's important is going to be x, okay, equals r times cosine of theta. And another one that's going to be important is going to be y equals r times sine of theta. These three things are so important for converting polar to rectangular and vice versa. All right, so here we go. A, r equals to cosine of theta plus 1. Right now, I know what r cosine of theta is, okay? But in your problem, it just gave me cosine of theta. So what I'm going to do is I'm going to rewrite my equation, okay? And from here, I would like to multiply both sides. Yes, you can do that, okay? What you do one side, you want to do to the other. And the reason I want to multiply both sides by r is that way I can get to this. Would you agree? I don't want to square both sides, which is also okay to do at times, okay? But squaring both sides here is not going to help me on the right side. So that's why we are going to multiply both sides by r instead of squaring both sides. Again, you can square both sides and you can multiply both sides by r. But squaring both sides on this one will not help us. Okay, so r times r is r squared. Co times r distribute, that's r cosine of theta. 1 times r is r. Can you see that this is right now x? Okay, now r squared, it's also x squared plus y squared. Remember, we're trying to convert it into rectangular. That means only x's and y's are left behind, okay? Now, this one says r is what I need to convert it out. Well, earlier, if r squared is x squared plus y squared, then r can be thought of as square root of x squared plus y squared. So yes, you can also drop it down just like that, okay? So this is as simplified as it's gonna get, okay? Now if your book, okay, moves it so it equals to 0, that's also okay. So what if your book moves this to this side and then this to this side as well? Okay, so that means it's x squared. They want to put all the x's together, no big deal. Bring down the y squared. Move the radical on the left-hand side. So now you have a negative radical squared equals 0. That's also okay too, if that's what the book has, okay? So if the book likes to write it equals to 0, it's okay. If you want to keep it as is, as long as it's in the simplest form, that's also okay too. So it's really up to you, okay? All right, next. R equals 3, okay? Now r is radius, right? So this is really saying radius is 3 units, right? With no angle given. Not funny, sometimes in polar coordinates they don't need to give you an angle, and sometimes they give you an angle without the radius. So I want you to think for a second, okay? What shape has a radius of 3 units all around, okay? Well, as you're thinking that out, I'm going to work this out manually. So they gave you r equals 3, okay? Now, this is the one that I will square both sides, okay? Because when I square both sides, now I have r squared equals 9. Unlike A, this one squaring both sides is still going to give me a nice solution, okay? Well, r squared can be now substituted with x squared plus y squared. That still equals to 9. I am done. This is all in rectangular form, okay? Well, think about it. We studied this already, okay? This is a circle, you're right, with a radius of of 3, okay? So this in rectangular will always be the same shape as polar, okay? So polar is usually more like graphing around, using angle and radius, but in rectangular we use x and y. Doesn't matter, sometimes we can still get the same shape. This is the end of example 6.